So today we're going to look at how we can deploy or update an SSL certificate on our overcloud. We're just going to do this on the public endpoints, and we're going to use DNS names. So you can do it two different ways. You can do it with IP addresses. So we create an SSL certificate with the common name of an IP address, so that when you go to it, you would go to https://IP address. Or you can do it with DNS names, so https://openstack.example.com. So we're just going to follow the documentation for TripleO, but we're going to deviate slightly because we don't want to use common names for our SSL certificate. We want to use the new standard for TLS, and the reason for that is that I run OpenShift on top of OpenStack, and Go has deprecated the use of common names in the SSL certificate, so we need to use the new standard. So for me, I don't need to recreate my CA certificate, but I'm going to go over that process in the video just to help anyone who might be interested. And then we will look at how we apply that in our templates and then roll that out to the overcloud. And we'll also take a look at how you can troubleshoot that, how it works from a manual perspective. So if your deployment failed, how can you manually apply the certificate to get everything back up and running? Okay, so first off, we're just going to start by just copy and pasting the command straight from the documentation. That's as simple as it is for the CA certificate. So once we copy and paste this, it's going to prompt us to answer some questions. So you just put in the details relevant for you. It's going to be up to you. The only thing to keep in mind here is we don't want the name of this certificate to be the same as the one we're going to generate for our actual overcloud. This is just our CA certificate. So for example, this section here where it asks for a common name, just put something like TripleO CA. So that creates our CA certificate, which we can see here. And we just want to make sure that's trusted by our system. So the next thing we do is we copy that one to our trust anchors for the director node, and we'll just call this one new overcloud CA cert, and then we update the trusts. So we just run this command. So that's it. That's as simple as it is to create the CA certificate. So for me, as I said, I'm not going to use that one. I'm going to use my existing one. This is my existing certificate. So if we were to follow the documentation at this point, we would now create certificates with common names for the fixed IP or the DNS names. But as I said, that doesn't work for things like the OpenShift installer, which uses Golang that has deprecated common name. Instead, it uses the SNI format of the DNS certificate. So what we want to do then is we want to create a file called server.csr.conf, like this. And in here, we're just going to paste the content that we want to create the certificate with. So that's mine, for example. Let's just fix up this formatting here. Bring that back a line. Okay, so that has all the details that I want to create my new certificate with. I might just change this. And then we want to create a file called v3.ext. v3.ext. And in there we will paste something that looks like this. But we see down the bottom here we've got alt names, and then we specify a DNS name that we want to use here. So again, we'll just quickly clean this up. And we'll change this to match the name we want. The last thing we want to do after we've created the key is just create the certificate. So we're going to run this command this time. So here we're just running with the in file being the server.csr that we just created in the previous command. The CA certificate will be the CA certificate we created earlier. The CA key will be the private key created with it, and then we will spit it out to a server cert.pem file. So there we go, we can see signature okay, we've got private key, we look here, we can see we've got server cert.pem. And if we do a verify on that file, so we're just doing OpenSSL verify, passing it the CA file we want to use to verify, and then the server cert.pem. We can see that one comes back and says that it's now okay. So if we go back to the documentation here, we can see that we now have 3 files that have been created. We have the root CA certificate, we have the SSL key, and we have the SSL certificate. So these files will go into our heat templates. So the CA certificate will go into the inject trust because it is a self-signed CA certificate, so we need to make sure all the overcloud nodes trust it. Then the rest of them will go into the enable TLS file. So again, we'll go back to my environment here and we'll cd to templates. So we have enable TLS.yaml. So in here, we want to, the first thing we're going to do is set the SSL certificate. So we copy and paste the contents of our certificate into this section. Then the SSL key, we copy and paste into this section. And this last argument tells it where that certificate is going to be deployed on our overcloud nodes. So if we log into our controller node and we cat that file, we can see that we have the contents of the certificate and the key here. So we can verify that they're the same. We'll just take a random string from the middle of the key, go back here and do a search on that string, which we can see comes up in the key section. So all it's doing is it's just concatenating these 2 items together and it's putting it in this file. And then if we take a look at the configuration for a HA proxy, just VI that file, we can see that all of these are using that same certificate to encrypt the endpoint. So this would have failed during the deployment. All we would need to do to manually do these steps and get things working and test it out is concatenate the key and the certificate into one file and replace the overcloud endpoint.pem on the controller node and then restart HA proxy. And that should be enough to get us back up and running if anything were to go wrong. So once we've updated those files, we can save that and we just want to then run a deploy, just a normal overcloud deployment. So here, if we were to cat server cert.pem and server key.pem into overcloud cert.pem, now we have a similar setup to what is on the overcloud nodes. So I can scp overcloud cert.pem to heat admin at 192.168.24.10, which is my controller node. We go back to the controller node, which is here. So we can see that I now have the file here. So what we'll do is we will copy the overcloud overcloud cert.pem. We'll copy it into this directory here. So etc pks tls private. Now for me, because the CA certificate didn't change in this run, I don't need to update the trust for the CA certificate. I just need to replace the file and restart HA proxy. So although I'm doing an overcloud deploy, I'm just going to show you as well, just for reference. So we'll just cd into that directory and I will make a backup of this file. So you can see I've done this a few times before. So we'll just copy that to backup demo and we'll copy overcloud cert to overcloud endpoint.pem. Override it, yes. So we'll look at PCS status to see our resources. Oh, we have failure there in Rabbit. It's back up running, so it's fine. All right, so we're going to restart HA proxy bundle. So that has been successfully restarted. And if we navigate to the URL, we can see that it is secure. It has a valid certificate. You can see it has your org, which is the one we just did, signed by TripleO CA. So that's it. We can see that that has worked. So now all I need to do really is I can just wait for this overcloud deployment to complete, which it should. Then I will also have the updated certificate. So hopefully seeing it like that helps to make sense of what's actually happening in the background for you. Like it just copies it, concatenates it into that one file and restarts HA proxy bundle. There's really no other magic to it other than that. The only thing to remember would be if you're doing this from scratch, say you're adding TLS to an environment that doesn't already have TLS, you'll need to make sure that CA certificate that you create is trusted by the overcloud nodes. And to do that, we would just run through exactly the same process we did on the director node. Just copy it to the CA trust directory, do the update CA trust extract command, and then you're in exactly the same position I just was then. So we'll wait for this to complete. We'll come back, do a bit of a recap. We'll go over why we used the different method compared to the documentation. I've actually submitted a change to update the documentation, so hopefully it will be updated soon. And then we will wrap it up. So once the deployment is complete, we can just check that it is using our updated certificate. So we can just run OpenSL S client, give it the server name, tell it where to connect. So we're going to connect to OpenStack BNE HomeNet on port 443, and then we're just going to check the dates. So we can see there that not before, and that is today's date, so Jan 25th, 2021. So we know that that's our new certificate that we created today. We know that that deployment has now worked. So just to recap, we'll just quickly go back to our documentation here. The first thing we do is we create a self-signed CA certificate, or if you have your own, you can use your own. If you do need to create your own self-signed CA certificate, then we need to make sure that the director node trusts it, and we need to put that into the inject trust file. So if we go back to the templates, inject trust anchor, so this is our SSL certificate here. Once we've got our CA certificate and the director node trusts it, we've added it to that file, we need to create our SSL key and our SSL certificate that we will use for the actual overcloud endpoint. Now we don't want to use the common name, we want to use the new standard for SANs and DNS names. So I'm going to leave the commands in the description below, and we will create our two certificates. So that was these two files in here. server.csr.cnf. So the first one is our CNF file with all the answers to the questions that it would ask when you run that command, and we can give that one the common name, that's fine. But the second one we want to do is this v3.ext file, cat v3.ext, and we want to make sure that we have SANs, so subject alternate name, and we want to make sure we give it the DNS name that we're going to be using. Then we can create our certificate. So the commands to do that are these ones here. So again, I'll link to these commands so we have all the commands. Once we've done that, we can go back to our docs and we can see that we have these three files. And if we just keep following along with the documentation at this point, it'll tell us where each of those files need to be placed. Then you just run an overcloud deploy. Now, if you were to run into any issues during the overcloud deploy and you need to troubleshoot, you can troubleshoot by concatenating the server certificate and the server key into one file and placing that in the directory over here. So we want to place it into etc pki TLS private, call it overcloud endpoint.pem, and then just PCS resource restart HA proxy bundle. And that's it. Once HA proxy is back up, we can navigate to the URL and we can see that it's now using our new certificate and everything is working fine. At that point, your deployment should be able to complete. You've just done exactly the same as what is happening when you run the deployment. If you do run into issues, it's probably because your certificate isn't trusted by the CA certificate, or your overcloud nodes don't trust it, or your client doesn't trust the CA certificate, but it's going to be something to do with the CA certificate and the relationship to the certificate you've created. So you can just go through and verify that they're fine just by running the verify command we saw earlier. pass it the CA certificate you've used and the server cert.pem file, and make sure that returns okay. If that returns okay, you should be fine. You shouldn't have any other issues. So I hope that that's informative, and I hope that it's somewhat helpful in helping you to understand what happens in the background, and it kind of demystifies a little bit of what TripleO is doing so that you can more confidently troubleshoot your own deployments and more confidently overcome any issues you might encounter.